Let's analyse another H-NMR spectrum.
Okay, so I've got a bit of an ugly spectrum here. Looks like it's been copied and pasted nicely from the internet. But first things first, we've got 4 unique hydrogen environments. So they've got 4 HNVs coming up in here. The next thing I'm going to look for is what integration or any indication of size of peaks. I can see here I've got a 6, I've got a 1 or a 0.91, so it's close enough to a 1. I've got a 1 here, and I've got this guy which is 1.94, so therefore I'm going to call him a 2. So what that means is how many hydrogens are in each environment here. I've probably got a CH2 happening here, a CH1, CH or an OH. Here I've probably got a CH, and here I've got 6 hydrogens. What that means is I'm probably going to have 2 lots of CH3s in the same environment. What that means is that these CH3s are probably going to be attached to a centralized atom, and there's going to be some symmetry about that particular region there, just based on the fact that to get 6 hydrogens in one environment, you're going to have some symmetry there. Next job is to look at my neighbours. So therefore this guy has been split into 2. So here for this guy is probably next to a CH. This guy here has been split into lots, so it's next to lots of hydrogen. This guy's not split at all, so chances are it's going to be the OH there. And over here, this guy's been split into 2 again, so therefore he's going to be next to a CH as well. Next job is to start looking at chemical shifts to see if there's anything interesting. This guy here is not interesting at all. He's right down this low end, so probably just alkyl groups. Moving up, you get into a region where there might be some oxygen present. Looking at this guy here, probably next to a C double bond to O, around about the 2 mark. This guy here, OH, because we think it's an OH, it could be anywhere really, so I'm going to ignore the chemical shift for that one. Up here, sitting around at the top end of the 3s, or the middle end of the 3s, again, might suggest ester functional group coming in here, or a C bonded to O there. So therefore, I'm going to suggest both these points here lead to esters. So therefore, let's have a look at that. Actually, not esters, it might actually be a carboxyl group. Let's see if I can get out with 1, 2, 3, 4 hydrogen environments and make a carboxyl or an ester based on that. So if I start off with carboxyl, that kind of makes sense because we've got the OH here happening as well. So they've got the carboxyl as an N piece. I've got these 2 CH3s, so let's put the CH3s here, and they're going to be bonded to a CH there. Now that CH I can see is here. It's going to be bonded to lots of things, obviously. And then I've got a CH2, so therefore let's go and chuck a CH2 there, and I think that's actually going to fit my molecule. Doing a quick check over, I've got my 4 environments, the splitting pattern works, and also the integrations fit, so this must be my molecule.